Okay, this is section 4.5, day 3 of Honors Pre-Calculus BC. And we are starting out here wanting to factor f of x is 2x to the fourth plus x cubed minus 24x squared plus 20x plus 16. So we have 5 terms kind of stuck right off the bat. So let's go into our p over q factoring. So let's find p. Those are the factors of the constant. So that's going to be plus minus 1, 2, 4, 8, and 16. And Q, that's the factors of the leading coefficient, so just plus or minus 1, plus or minus 2. And then P over Q. All right, all the combinations of these P over all of these Q values. So let's start with just everything over 1, which is exactly that, exactly P. So plus or minus 1, plus minus 2, plus minus 4, plus minus 8, plus minus 16. Then we have to get all of these all over 2. So plus minus half, plus minus 2 over 2, which we already have is 1. 4 over 2, we already have is 2. 8 over 2, got that one, that was 4. And 16 over 2, 8. So that's all of them. Good. All right, now let's just start running through here. And let's start at 1. I'm putting a 1 into here. 2, 1, negative 24, 20, 16. Synthetic division, bring the 2 down, multiply, that's 2, adds 3, multiplies, 3, add, negative 21, multiply, add, multiply, 15, remainder 15. So positive 1 is out. Let's try negative 1. 2, 1, negative 24, 20, and 16. 2 multiply, that's negative 2, adds negative 1, multiply 1, add, that's negative 23, multiplies 23, add 43, multiply, negative 43, add, negative 27. So negative 1's out. Let's try 2. Let's see, we're going to have 2, 1, negative 24, 20, and a 16. 2, multiply, that's 4, add, 5, 10, negative 14 times 2 is negative 28, add, that's negative 8 times 2, negative 16, remainder 0. Yay! So that means that 2 is a 0. 2 is a 0, so x minus 2 is a factor. All right, now we have to try again. Because 2 worked, we want to try 2 again in that depressed polynomial. So let's try 2 again into 2, 1, negative 24, 20. Oh, that's not right. I just said the depressed polynomial, and then I started writing the original. Sorry. All right, so depressed polynomial. 2, 5, negative 14, negative 8. Bring down 2, multiply, that's 4. Add, that's 9, multiply, 18, add, that's 4 times 2 is 8, remainder 0. Yay! All right, so what does that mean? That means another 2 is a 0. So we have another factor of x minus 2. Okay, now this is down to a quadratic. So take this 2x squared plus 9x minus 4. Did I say minus 4? Silly. Let's go. We're going to take this into 2x squared plus 9x plus a 4, set it equal to 0, and then factor. Let's see, 2x, 2 and 2 isn't going to work. Let's try a 4 here and a 1 there. Yeah, there's 8x on the outside terms and a 1x on the inside term, which is going to give us, from this one, x is negative 1/2, and from over here, x is negative 4. There's your two remaining zeros right there. And then the factors that are produced, well, this one's easy to see. That one's just x plus 4 is a factor. This one, though, you could do x plus 1/2, but if we wrote x minus 2, another x minus 2, an x plus 4, and an x plus 1/2, then the leading coefficient, if we multiplied that all the way out, would be just an x to the 4th. But we need this to be a 2x to the 4th. So what happens is we don't want to write this factor as x plus 1/2. We want to write that factor as 2x plus 1. And if you think about that, 2x plus 1, set that equal to 0, solve it, you will get x is negative 1/2. So our answer to this problem says factor this. F of x is x minus 2 quantity squared times an x plus a 4 times a 2x plus 1. There we go. Okay, now, even though I didn't put it up there in the directions, I would like to go through and sketch a graph. Okay, we know we have a 0 at 2, and actually it's a multiplicity 2 zeros, so that one's just going to touch. We have a 0 at negative 4, and it's odd multiplicity, so we cross through, and we have a 0 at negative 1/2 right there, and we're going to cross here. Degree 4, positive leading coefficient, so both ends up. See, cross here, touch, and back up. Oops, let me move this up so you can see it. Sorry about that. There we go. All right, one last thing that I would like you to put into this graph, just so you can see out of scale it really is. Can you find the Y-intercept? And we can find that really quickly by going back up to the original equation and plugging in x is 0, and we'll get 16. So this point right there is at 0, 16. Very definitely this graph is drawn out of scale. All right, now let's look at something called the intermediate zero theorem. And the intermediate zero theorem says let f represent a polynomial function. If f of a and f of b have opposite signs, then there is at least one real zero between a and b. Sounds complicated, but when we draw a picture, it's really not. Let's choose some spot A right here and some spot B right here. This just says if f of a, the y value at a, and f of b, the y value at b, have opposite signs. So one of them's positive and one of them's negative. Let's make this one positive and let's make this one negative. We have to have a polynomial function, so that means it must be smooth and continuous. have something like that? Got a little messy in here, but that's all right, we can fix it. Sure, that could be a polynomial function. And here's what it says. So we have some polynomial in between here where f of a and f of b are opposite signs. Then there is at least one real zero between a and b. All right, so here's what this says. If you're going from a positive y value to a negative y value, you must cross through 0. Oh, not you, but the function must cross through 0. That's it. Could it cross more than once? Absolutely. We could make this thing bounce around in here and cross more than once. But it has to cross the x-axis at least once. All right, now we are going to use the intermediate value theorem to show that f of x equals 2x cubed minus x minus 3 has a 0 between negative 2 and 4. You need your calculator for this. Please take out your calculator and go along with the button pushing with me on this one. You're going to have to do this on a test, so it's important that you can do this. If you're missing the button pushing information, then just stop the video, rewind it a hair, and hear the directions again. All right, use the intermediate value theorem to show that f of x is 2x cubed minus x minus 3. It has a 0 between 2 and negative 4. What we need to do with this is we have to show that the y values have different signs. Okay, so let's find f of negative 2, and let's find f of 4. All right, I want you to put this into your calculator. Let me turn my contrast down so you can see this. All right, so go into y equals. Somebody did something to my calculator. Hold on, I have to fix this. Somebody put transformations on it. I'm sorry, I didn't know it was there. I'm going to quit this. Okay, all better. It had that weirdo symbol right here in front of the Y1, and I didn't want that because I just don't. So if yours has that and you want to take it off sometime, I will be more than happy to show you to do that. All right, so we're going to put this equation in here. So 2 x to the third minus x minus 3. Again, if you are not doing this with me, shame on you. I want you to do this with me. All right, now do not graph it. I don't want you to figure this out with graphing. I want you to do this without graphing. Okay, so now go back to a home screen, which is second quit. Should be blank. If it's not, hit clear. All right, I want you to find this function at negative 2. So you have to evaluate this function at y1. So to get that, we're going to go alpha f4 y1 at negative 2. So your calculator is really doing function notation. Enter, and it gives us that f of negative 2 is negative 17. Let's find f of 4. Again, alpha f4 y1 at 4, and that gives us 121. Right here, this tells us there is a sign change between the y values. Therefore, there must be at least one 0 between x's negative 2 and 4. There is a sign change in the y values. Therefore, there is a 0 between x equals 2 and, negative 2 and x equals 4. All right, now without graphing, find a 0 accurate to consecutive hundredths. Without graphing. And I know you just want to hit graph on this one and do it that way, but I really want you to see this another way. It's just some more information about your calculator. So what I want you to do is to go to the table, which is second graph. And you should have x here and y 1. And perhaps you have the same x values showing that I do, perhaps you don't. Doesn't matter. All right, what I want you to do is we want to look for, well, let's go back. If you don't have the same x values, let's talk about setting that table. So go to second window, which is table set. So second table set. And we should have our table start. Where do we want to start looking? Well, in this case, because we're looking in between -2 and 4, let's start our table at -2. And let's delta table or increase those x values by 1. That's 1. And keep both of these on auto. Now pull your table. And we should all have exactly the same thing. All right, what you're looking for here is you're looking for a sign change in the y values. And a sign change in the y values is occurring right here between this y is -2 and that y is 11. Now, to show this on paper so that you are showing me this properly, what I would like you to do is you're going to make a small t-chart here. You're not going to produce everything. You're going to find the sign change in the y values, which is -2 and 11, and then you're going to go up 1 and down 1. So that's going to send us from x is 0, 0, 1, 2, 3, and then at 0, the y is -3. At 1, the y is -2. At 2, the y is 11. And at 3, the y is 48. Okay? Now, I want you to identify this on paper so that somebody reading can figure out what you're doing. So right here, we're going to say there is a sign change in the y values. So there is a 0 between x equals 1 and x equals 2. All right, now we're going to go just a little bit closer. So this time go back to your table set. And we know the 0 now is between 1 and 2, so let's start our table at 1. And this time, instead of incrementing by 1, let's increment by 1/10. So 0.1. And pull the table again. And we're looking for a sign change in the y values. And we see a sign change right here between x is 1.2 and 1.3. So we're going to copy a portion of that table, just one up from the sign change and one down from the sign change. So we need to be at 1.1, 1.2, 1.3, 1.4. At x is 1.1, our y value is -1.438. At x is 1.2, our y value is -0.744. At x is 1.3, our y value is 0.094, and at x is 1.4, the y value is 1.088. Again, you have to explain what you're doing here and what you're finding. So we see right here, there is a sign change in the y values. So there is a 0 between x equals 1.2 and x equals 1.3. All right, right now we have our 0 between 1.2 and 1.3. That's between consecutive tenths. We need to be accurate to consecutive hundredths. So we're going to have to go one more time here. So go back to your calculator and table set. We know this time we want to start at 1.2. We want to go up by 0.01 every 100th. And pull that table. Now scroll through, and sometimes you have to scroll through a bunch to find the sign change. This one not so much. Ooh, it's right there between 1.28 and 1.29. And if we copy that portion of the table, again, one up, one down, so 1.27, 1.28, 1.29, 1.30, 1.27 is at negative 0.1732, 1.28 at negative 0.0857, 1.29 is at positive 0.00338, and 1.30 at positive 0.094. Okay, so right here we see a sign change in the y values. So there is a 0 between x is 1.28 and x equals 1.29. And now we are at consecutive hundredths. Okay. Again, if you missed part of this, the button push directions, pause the video, rewind, go back and hear those directions again. Thanks.